Marketing Stats fans, how we doing on this fine Tuesday morning? It's a little cloudy outside, a little chilly outside. It's going to get a little bit worse this week, but hopefully by next week we'll get some nice warm weather, and hopefully they're wrong for this weekend. We'll keep our fingers crossed on that one. We want to make sure that we get some warm weather. We are close to the end. We have some hypothesis testing on variance and standard deviation. We'll deal today. Tomorrow we'll work on some comparing two means, and that will be pretty much the last of the topics that we will deal with, the comparison of the two means. And then we'll start reviewing for a chapter test over hypothesis testing, and then we will go into a final and start prepping for a final. So the end is near. It's getting close, folks. So please do keep up with the material so we don't get bogged down as we go forward. Try not to get bogged down. Keep on top of things. I'm trying to pace this out, so it's a very doable process if you sit and get some work done. It's a very doable process for you. So hopefully you are continuing to maintain what you have to do, and then you don't have to binge study and binge work and try to get things done by a binge. Today we'll deal with hypothesis testing, testing for variance and standard deviation. Once again, state the null and alternate hypothesis. Identify if it's one tail or two tail, left or right. We have a degree of freedom of n minus 1. Find our critical values from our table. Okay, critical values. If it's a left tail test, if it is only a left tail test, okay, you use alpha 1 minus alpha. Okay, and what you can do on your chi-square table, you can write in your margins. Left tail test, use 1 minus alpha. If it is a right tail test, you just use alpha. And if it's a two tail test, you're going to use 1 minus alpha divided by 2 and alpha divided by 2. These are defined your critical values. And once again, you can rewrite this on your chi-squared. I always tell the students when we're going through this, write it on your chi-squared table. I don't remember this, so you're not going to have to sit there and memorize what do I have to do if it's left tail or right tail to find your critical values. I'm not going to go to that point. And we use, if it's a right tail, we just use alpha. If it's two tail test, we use alpha divided by 2 and 1 minus alpha divided by 2. So that's how we find our critical values. And with that, you have a degree of freedom. And you do a bell-shaped curve. Now, I know if we look down here on your chi-square table, it's not quite a bell-shaped curve. I don't sit there and say, you know what, I'm going to try to draw a curve like this. I still do a bell-shaped curve because half the time my bell-shaped curves may look like that anyways. So, okay, they have a little, the hump on Sally the camel is pushed this way a little bit. I still utilize a bell-shaped curve, and you still want to deal with your critical values, whether it's a left tail or it's a right tail or if it's a two tail. The test value for the chi-squared value is your degree of freedom, your sample variance divided by your population variance. Okay, once again, you are going to be trying to test a hypothesis for the population variance. Okay, so this is our population standard deviation. So this here is your population variance that you're trying to test. Because what you'll deal with is your null alternate hypothesis. We will be testing variance or standard deviation will be less than or greater than or equal to or greater than, less than, or not equal to. That's going to be the same. And this could be variance and it could be standard deviation. It could be one or the other. So you may be dealing with sigma squared for the variance or the standard deviation that you'll be comparing. So you'll have to be able to read the verbiage from the problem to be able to come up with that. Now, other thing to note here is this is S squared. So if you're dealing with a standard deviation, you need to be able to square that. But if you're given the variance, this value is already squared, so you do not have to square it again. So once again, you need to know the verbiage of the problem. If the problem says you're looking at the variance, this is going to be all sigmas. All these are going to be sigma squareds. And this will be sigma squared already, and they'll probably give you the variance within the problem also, so you do not have to square it. But if they give you the standard deviation and want you to test the standard deviation, then you're going to have to square these values. So you have to be able to read the verbiage of the problem. And if the test value is in the critical region, you reject the null hypothesis. A weather service claims that the standard deviation of the number of fatalities per tornadoes is more than 25. A random sample of a number of deaths in 28 years has a standard deviation of 31 fatalities. Use an alpha value of 0.10. Is there enough evidence to reject the weatherman's claim? First thing that we need to note here, and you may want to underline it, is the idea of the variance or the standard deviation. What are they giving me here? They want me to compare the standard deviation and the variance. Well, here they're dealing with the standard deviation. So we have a standard deviation is more than the value of this 25. Because they're saying what they want to hope is true is an established value, they want it more than 25. So they're saying, is my standard deviation more than 25? That means by SpongeBob opposite day, I have less than or equal to the value 25. If we take a look at this problem, is it one tail or two tail? Well, if I have less than and greater than, it's one tail. And since I look at my alternate hypothesis, this will be a right one-tail test. So if I take a look at what we have here, we have a sample of 28 years, n is equal to 28, which means my degree of freedom is 27, 28 minus 1. We have a sample standard deviation is 31. And we have an alpha value of 0.10. So if we look at our bell-shaped curve, once again, I know it's supposed to be more pushed this way. It's like a skewed to the right. I still use my bell-shaped curve because it's just easier for me. This is going to be a right tail test. So I'm going to draw in my critical value on my right tail. This is non-critical. This is critical. We have to find a critical value, so we look at our alpha value. And from what we did up above, when I'm dealing with a right tail test, we're just using the alpha value. So if I go to my chi-squared table, make sure it's a chi-squared table, not your t-table. We have an alpha value of 0.10. I'm going to take that down to a degree of freedom of 27. And what you should get is 36.741 is your critical value. Now if we look at a chi-squared test value, this this is equal to n minus 1, or degree of freedom, s squared divided by sigma squared. Now, once again, it's key to note that what we are given is the standard deviation, which is just s and sigma. So we have 27, we have s squared, which is 31 squared, over sigma squared, which is the value 25. And we have to square that also. Once again, if the variances are given to you, I'm not squaring this, the variance is already squared. So we have 27 times 31 squared divided by 25 squared, and we get 41.51, which throws me out here in a critical range. So we can reject the null hypothesis of the standard deviation that is equal to 25 and is more than 25. Now, we're just saying it's more than 25, we don't have an exact value. We could sit there and say it's 31, and we could start testing the value of 31 if we wanted to. We can establish a value at that point, whatever we want to do. A doctor says the standard deviation of length stays of patients involved in crashes in which a vehicle struck a tree is 6.14 days. The random sample 20, the length of stay, patient's type has standard deviation of 6.5 days. Alpha value 0.05. Is there enough evidence to reject the claim? So I take a look at the doctor saying it is 6.14 days. And they're not really saying anything else other than it is 6.14 days. So if I'm writing my null and my alternate hypothesis, equality always goes with the null hypothesis. And we can also take a look at, we're looking at the idea of standard deviations. So we have sigma is equal to 6.14 days. Why did I put it with the null? Because equality always goes with the null. That means over here sigma is not going to equal 6.14 days. So if we take a look at this, do we have one tail or two tail? Right, two tail. So if we take a look here, his study came down to a standard deviation of 6.5. We had a sample size of 20, so degree of freedom is 19. We have an alpha value of 0.05. So if we go to our curve, whoopsie, try that again. If we go to our curve, once again, I know it's not a chi-square curve, but that's okay. Get my two tails in. Need to find critical values. For critical values for a two tail, once again, I suggest just write this on your chi-squared table. Write it down at the bottom. On your chi-squared table, two tail, use 1 minus alpha, or alpha divided by 2, and 1 minus alpha divided by 2. So we have alpha divided by 2, which is 0.05 divided by 2. So you take your 0.05 divided by 2. And you get 0.025. And this 1 minus alpha divided by 2 is, so we have 1 minus that. we get 0.975 as our second value. So we can go to our chi-squared table, a degree of freedom of 19. I look at my alpha value along the top at 0.025 and string that down to degree of freedom of 19, 32.852. And then a 0.975, I take that down to 19, I get 8.907. Non-critical, critical, regions, making sure my values are right, 8.97 and 32.852. Okay, chi-squared test. We have our degree of freedom, which is 19. Once again, this is not being squared, so we have 6.5 squared over 6.14 squared. So clickety-clacking, we have 19 times 6.5 squared divided by 6.14 squared. We get 22.69. 22.69. So at that point, we fall into a non-critical region. So we failed to reject the null hypothesis. Of standard deviation for lengths of the stay. Is 6.14 days. Which means we support the doctor's claim that it's 6.14 days. We don't have any evidence to say it's different than that. So this is hypothesis testing for your standard deviation or your variance. Once again, if your variance is up here, this turns into a square, this turns into a square, this is going to turn into a square, which means when I calculate my test value, I don't have to square the values. I just pull the values that are given to me already. So you need to watch yourself. You need to pay attention to the verbiage as you go through the problem. Other than that, I have nothing else for you today. This is sample standard deviation, or I'm sorry, hypothesis testing for your deviations. This week, what we'll do some ideas in regards to comparing two means. Probably do an in-class assignment, a combination of all these put together, and then start prepping for a final, not for a final, a unit test over this material, and then start prepping for a final in the classroom. Other than that, I have nothing else once again for you. I hope you're safe. I hope everything's going well at your household. I miss you guys. I wish we were back in school, but we're not. So we'll just keep on plugging along. Please do keep up with the material. You guys are doing a very good job of doing that. Just keep up the good work. Other than that, adios. I'm out of here. Folks, have a great day.